The objective of this video is to learn how to conduct a chi-square hypothesis test for a single variance. A zoologist is studying the effects of captivity on a certain species of tiger. She has collected the weights of a sample of 15 adult tigers of this species that were raised in captivity and found that the variance for the sample is 17.39 kilograms. Previous studies have shown that the variance for the adult weights of this species when raised in a natural habitat is 18.66 kilograms. At a 0.05 level of significance, test the claim that the weights of adult tigers of this species when raised in captivity have a smaller variance than those raised in their natural habitat. There are three assumptions that must be met when using the chi-square test for a single variance. 1. The sample must be randomly selected from the population. 2. The population must be normally distributed for the variable under study. 3. The observations must be independent of one another. Step 1 is to state the hypotheses and identify the claim. The null hypothesis will be that the variance is equal to 18.66. The alternative hypothesis will be that the variance is less than 18.66, which is the claim. Step 2 is to find the critical value. In the chi-square distribution table, we have the values of alpha in the top row, the number of degrees of freedom in the left column, and the body of the table contains the chi-square critical values. Chi-square values are always positive. The areas in the top row of the table correspond to the areas under the curve to the right of the chi-square critical value as shown in the graph. Since this is a left-tailed test with a level of significance of 0.05, we will find 95% or 0.95 of the distribution to the right of the chi-square critical value. The number of degrees of freedom for this test is one less than the sample size. Our sample size is 15, so we have 14 degrees of freedom. The column headed 0.95 and the row with 14 degrees of freedom intersect at the chi-square critical value 6.571. So the critical value is 6.571 for alpha equal to 0.05 and 14 degrees of freedom. Step 3 is to compute the test value. The chi-square test value requires that we know the sample size, the sample variance, and the hypothesized population variance. Substituting these values into the formula, we find a chi-square test value of 13.047. Step 4 is to make the decision to reject or not reject the null hypothesis. It is always a good idea to visualize the orientation of the critical value and the test value by placing them on a graph of the hypothesized distribution. If the test value lands to the right of the critical value in the left-tailed test, we do not reject the null hypothesis. In this problem, we are to test at a 0.05 level of significance. We have determined the chi-square critical value so that 5% of the distribution lies in the rejection region. That would leave 95% of the distribution to the right of the critical value. Therefore, it would be very unlikely that a randomly drawn sample would lead us to commit a type 1 error, which is to reject a true null hypothesis. Our calculated chi-square test value of 13.047 clearly lies where we would not reject the null hypothesis. So our decision, then, is to not reject the null hypothesis. Step 5 is to summarize the results. Since we decided that we would not reject the null hypothesis, our conclusion is that there is not enough evidence to reject the claim that the weights of adult tigers of this species when raised in captivity have a smaller variance than those raised in their natural habitat. In this video, we learned how to conduct a chi-square hypothesis test for a single variance.